So we have reason to believe the planetary migration hypothesis because it explains a great deal of observations that otherwise wouldn't be understandable. It explains hot Jupiters and other solar systems. It explains the asteroid belt, the Oort cloud, the late heavy bombardment in our own solar system. And it does so for those last three by a single mechanism, that of gravitational resonance, which is a well-known scientific phenomenon. But remember that according to the scientific method, we can't accept a hypothesis simply because it explains already known observations that it was developed to explain. We also need to make observable predictions and then look for those observable predictions. So, does the planetary migration hypothesis make any observable predictions? Well, yes, it does. One of them is this, that if gas giants formed far from their star and then migrated inwards, then what happens to them when they get closer to the sun? Well, as they get closer to the sun, the gas particles of their atmospheres will begin to move faster and should escape off into space. So these gas giants should actually evaporate. They should lose their gas as the particles speed up and the gases are blown away by the stellar wind as they approach the sun.
The Earth, the planet on which we live. It orbits around our star, the Sun, at a safe distance of 150 million kilometers. But not all planets are so fortunate. In the latest issue of the magazine Nature, astronomers report the first observation of an evaporating extrasolar planet, its atmosphere boiling off into space. Most of the planet may eventually disappear, leaving only a dense core. This observation sheds new light on the fate of gas giant planets that spiral in, close to their parent stars, drawn to them like moths to a flame. A team of astronomers used the Earth-orbiting NASA ESA Hubble Space Telescope to observe the planet as it crossed the face of its parent star. The observations were made in ultraviolet light. Hubble's position above the atmosphere makes it the only telescope that can perform this type of observations. The parent star HD 209458 is similar to our Sun and lies 150 light-years from Earth in the constellation of Pegasus. In 1999, this star suddenly entered the Astronomical Hall of Fame when the extrasolar planet was seen passing in front of the star and partly eclipsing it. The planet orbits at a distance of only 7 million kilometers from its yellow sun-like star. Its atmosphere is heated so much that the hydrogen escapes the gravitational pull of the planet and fans out in a giant comet-like tail. Although the planet is too close to the star for Hubble to photograph, it blocks light from a small part of the star during the transits as in a partial eclipse, thereby dimming it slightly. This new discovery may help to explain why extrasolar planets seem to pile up in orbits a few million kilometers from their parent stars, but are not found much closer than HD 209458b's distance of 7 million kilometers. The planets orbiting closer may simply evaporate away so quickly that they are unlikely to be discovered.
So a successful prediction from the planetary migration hypothesis gives us one more reason, and a strong one, to accept that this really happens. But of course that raises another very, very significant question. Why didn't this happen with our solar system? Planetary migration hypothesis plus nebular theory suggests that our solar system shouldn't exist. We started off believing that 51 Pegasi b shouldn't exist. We come now to the place where we think our solar system shouldn't exist. So how can we possibly explain the fact that our gas giants are not and have not spiraled in towards their sun? Well, we think it was actually a result of a very, very, very specific formation of our gas giants. We formed 4 gas giants, all in the right place with the right sizes forming at the right time to stabilize one another. And actually, we believe that largely the formation of Saturn, but the other gas giants actually pulled Jupiter back out from the inner solar system and set it down in the place where it is today.
It stopped. Jupiter's invasion of the inner solar system is mysteriously halted. The planet makes a turn, or, in sailors' parlance, a grand tack. Lurking behind Jupiter is a second gas giant, Saturn.
So as Jupiter was migrating inward, Saturn was following it and growing. And as Saturn was growing, it came to have a size that it had a gravitational impact on Jupiter, which became more important than the gravitational interaction between the gaseous disk and Jupiter. They reverse direction.
So in fact, what we end up discovering is that our solar system, which we thought was typical, is actually very, very special. If there hadn't been the formation of just the right number of gas giants with just the right mass in just the right place at just the right time, then it seems that Jupiter and Saturn and Uranus and Neptune would all have migrated inwards, completely disrupted the planets in the inner solar system, and eventually vaporized as they got closer and closer to the sun, and there would be no Earth and no life on Earth.